Welcome to Engineered for Impact, a podcast helping engineers learn and think more about how they can have a positive social impact with their careers. In this episode, I talked to Lennart Heim, a research fellow at the Center for the Governance of AI, who has a background in electrical engineering. Our discussion centers on the use of computational resources as a governance mechanism for the safe development of artificial intelligence. We cover what AI governance is and how Lennart came to be working on it, the US export controls on AI chips and the recent developments in the AI landscape, the so-called AI production function and why compute may be the most promising input for governance, the AI compute chip supply chain, potential ways to do AI governance through controlling or monitoring access to compute, and finally, why engineers might be particularly well suited for the field and how to get into the field. You'll find show notes with valuable resources related to the episode at engineeredforimpact.show/Lennart. That's Lennart. If you enjoyed this episode, please head to the website and leave us anonymous feedback and share it with a friend or colleague. So, without further ado, here's Lennart.
My name is Lennart Heim. I'm a researcher at the Center for the Governance of AI, short GovAI, and I'm working on our research stream, which we call compute governance, where we try to use compute as a node for AI governance. With compute, we mean something like computational power, computational infrastructure. I'm also part of our policy team, so I'm trying to do things right now in the world to make sure the transition to a world with advanced AI eventually goes well.
Terrific. Well, I'm definitely looking forward to diving into compute governance and where you think engineers can kind of fit in around that. But I think it'd be good to start with to maybe lay a bit of context and foundation for why we're interested in compute governance and why we're interested in AI safety as sort of like a foundation towards wanting to have something to govern.
Yeah. What do we mean with AI governance? I think AI governance there's like the AI governance field, and there's like the technical AI safety field, alignment field. And AI governance is basically everything which is not too technical, which in itself does not make the systems more secure. So like it generally governs like how do we make decisions around AI and their deployment and development. This can be in governments, this can be in labs, this can be in think tanks like I am, many places where important decisions regarding AI are being made. Why should we care about AI? Why should we try to govern it? Well, I think we kind of witnessing it right now. So we're recording, GPT-4 was released a couple of weeks ago. I think even though our moms and grandparents have heard about AI recently on TV, everybody's kind of waking up to it, and it seems like it's a big useful tool, right? And there's some risk which eventually can come from the systems already right now, but potentially even more in the future. And I'm particularly focused on future risk from advanced AI systems, which can have up to AI takeover scenarios or existential risks from AI.
Terrific. So how did you actually get from studying electrical engineering to working in AI governance?
Yeah, that's a long story. You just stop me where I should go, where we go.
You go for it.
I studied electrical engineering. I think as many people listen to this, and I'm I just want to know how computers work. And I basically got to this question to my brother. I was well, I want to know how computers work. I want to study something. I'm going to do computer science. He's no, computer scientists have no clue how computers work. You got to do electrical engineering. And then you can also make robots move. I'm robots sounds great. That's my thing. I want to make robots move and LEDs blink. And I think another motivation was just I grew up as a gamer. I played a lot of computer games. I was always fascinated by this. Kind of learned how to use these systems. At some point, just became the guy who was always setting up the presenter in school and just fixing these kinds of things. I'm still sometimes people still call me to fix the printer. So I think this never really changes. And was in general thinking hey, electric engineering, this whole computer stuff could just be a big deal in the future. I was mostly thinking about positively. I was seeing the emergence of we had something more local in Germany, which was similar to Facebook, but then Facebook was I was this seems great. Now the whole world can talk to each other. I think I changed my mind on this. I was it's not obviously good. But back then I was naively, wow, technology can connect the world. It seems really, really, really good. I should try to work on this. This seems really, really important. I think there was always some type of impact thing before. I was I'm trying to think about how can I change the world ideally to something positive. Studied electrical engineering, met a friend who was vegetarian. And I was interesting. Tell me more about this. Watch some documentaries. Like, yep, nodding. Gosh, you got me there. This makes a lot of sense. Joining this one. And then later, I tried to join some political parties and just do some stuff there. I was like, yeah, this seems important to get engaged there. There was like a big vote in Germany. I just joined a party to vote against like something. It didn't happen, so I left again. Tried to become more involved with the local parties. And I was like, man, like you miss like some kind of sciencey aspect. I still like vaguely remember talking about nuclear stuff and everybody was against it. I was like, this doesn't make sense. Like, can we at least like talk about the pros and cons? Like this doesn't seem too bad. Like this would be one way to solve like this whole climate thing. And then stumbled across the book Doing Good Better eventually. Read this, like, yep. Just again, a lot of nodding along reading this book. And found like a couple of other people in my university town in Aachen who were also interested in this. Got to know them. I was like, here we go. Here's the scientific mindset to do good and talk about all of the other stuff with a lot of other overlap of stuff we talked about there. And what we eventually at some point did is just reading Superintelligence. This was 2019 or 2020 or something. Reading Superintelligence, like, wow, this AI thing seems like a big deal. I think it was not as vivid. Now looking back at it, it's like, yeah, like, where did you see AI systems? Siri was kind of crap. Like, most things were, like, not that impressive. Did read Superintelligence. Was like, yeah, seems like a big deal. I should try to work on this. Tried to look up some stuff with my whole group. We were, like, all doing some engineering type of thing because it's pretty big in the town where I studied. And we all came away with the impression, like, well, there was like this machine intelligence research institute, MIRI. We looked at the research, like, well, I thought I'm good at math, but no, like, no way. Like, I just cannot contribute. Like, I'm out there. And I was like, okay, guess it's not the thing. I'm just going to do something, maybe donate some money. And just like try to continue exploring, just like things, just like general discourse of like donating better, giving certain percentage of your income away seems like a good idea. And at some point re-encountered, still like always thought about AI, never really thought I can do something there because I was an electric engineer. It's like, all I can do is build better hardware. That seems bad, right? I should not just join this company, build better hardware, like to accelerate this AI development. And there's nothing better about hardware. There's like no aligned hardware. There's like no hardware with like, which multiplies the matrices in a way like that they actually like have a good outcome with AI systems aligned, right? So this doesn't work. I was like, yeah, I guess there's nothing I can do. And at some point I stumbled across the blog post from OpenAI, which is called AI and Compute. And this blog post basically says like, well, the compute to train AI systems has been doubling every 3.4 months. And now you need like supercomputers to train these systems. I was like, yeah, that's thing. Seems like compute is really, really important. And then I kept just away like, okay, if it's that important, then you cannot just like give it to people or take it away from people, like a really blunt tool, but to some way you can steer the development. And as a minimum, you can understand the development. And the main reason I was interested is like, well, everybody talks about Moore's Law. Everybody talks about exponential progress in performance computing. Seems like AI relies a lot on progress in computing. So somebody should like figure out what is the impact of compute to AI. And then I did a research project basically looking to the role of compute for AI, for the AI production function, you could say. And where does it matter? Where does it matter regarding AI capabilities, regarding AI forecasting, and eventually also like compute governance? Now, how can you use this tool? And I did it. I came with this conclusion, like, this seems important. Somebody should work on this. Why is nobody working on this? First thought, well, nobody's working on this. Probably it's important. I must be wrong. Lucky me, I talked to people and they were like, no, actually what? This seems important. We just don't have a lot of technical experts eventually in this kinds of field. You should maybe do this. And then I started working more on this and eventually joined GovAI, and now I've been working on this full-time for more than 2 years. Yeah, that's the rambly story. How it kind of happened.
No, that's terrific. Yeah, fascinating that it stemmed from almost solely from just talking to a vegetarian, and now you're working in AI governance as a almost direct result of that interaction. That's pretty funny.
It's a long path, yeah. No, like working on this AI stuff, it's like still kind of weird to me. It's like, I think a bunch of my friends is still like looking at me and say, oh, Lennart, he was this guy who like wanted to do like for social justice, equality. And then he's doing this AI stuff. Like, what the hell? Like, where did he go wrong? And now in the recent weeks or like recent months, it's just like, I get it. I know where you're coming from. So it's like, yeah, it's like my favorite band is now becoming mainstream. So I feel a bit bad about it, as always, when your favorite band becomes mainstream. It's like, okay, actually people now get like this angle. Like, this is actually really important. This is like actually a big deal.
Yeah, certainly with the recent developments just over the course of the first few months of this year. the public discourse has shifted so dramatically around all of this. And then with like the letter as well for the moratorium, that was in major sort of common news outlets in Australia, which is, it's just interesting to see something that I'd seen only in sort of smallish corners of the internet and of the effective altruism space, suddenly being plastered on news feeds and on the TV and things like that. It was a bit surreal.
Yeah, it feels kind of surreal. There's like we got a new motto on the team, which is like, this is the new normal. Because just like the last few weeks, moms have just felt like, what the hell? Like so much stuff, so many good opportunities that I was just like trying to make a dent. But also you just need to act so swiftly now. It's like, ideally you would have had like, I don't know, I could have started 10 years ago and like think carefully about stuff and now have it ready. But I'm just like, no, you got to deliver. Things are moving fast. And this is the new normal. Yeah, everybody's chatting about it. Everybody wants to do something. What eventually is coming out of this? I don't know. Let's see. I think this year will definitely be a turning point and like the start of a new era.
Yeah, it's interesting, the new normal perspective or the new normal take that you've got on it. That makes a lot of sense, but I'm curious as to like, how has that changed in the last like 5 months? How has your work changed and just shifted as a result of all the talk that's now out there about it?
I think my new normal started a bit earlier, like on October 7th, 2022, the US did like some chip export controls. I was like, oh wow, the thing which I'm thinking about is now mainstream. They're now restricting access to chips. They're not going to China anymore. And this is a question which I've been thinking about before, trying to exactly figure out how you should do this. And they did this rule, but it's only an interim rule. So they also asked for feedback on this. I was like, oh gosh, I guess I now have a couple of weeks to think about what I think about this. Ideally, I would need here 5 years to think clearly about this, but you don't. So I got a couple of weeks to think about this and give them my best guess. If this is a good idea, how could they adjust it? What are like the details there? I think that's when it kind of started for me, like first, this thing becoming kind of mainstream. And I think then just the next one was like ChatGPT. When this was released, it's like, oh, now this tool is actually useful. Everybody's chatting about it. Twitter is full of it. And yeah, I think then a continued ChatGPT moment. And I remember I was in Washington, D.C. before the October controls, around end of September, beginning of October, actually. And you talked about it and people were like kind of interested or something, but not too much. And then we were there again in March after ChatGPT and just the sentiment changed. And the week we were there, actually GPT-4 got released. And like literally like, yeah, while going from think tank to think tank, like my colleague was prepping his slides and like actually adding GPT-4 just to the slides for the talk we were giving next. It's like, oh, wow, it just passed the bar exam. People will love it. So they get it now, right? Just like in this, like how fast pacing these kinds of things are, right? And then after weeks, just like, yeah, as you just said, the FLI letter and like all of this other stuff is just like way more public attention. And it's just like major news outlets just reporting of it. And then most recently, just like big names within the field of AI and computer science, Geoffrey Hinton and others, just like coming out, it's like, yep, this is a real risk. We should talk about it. And I think the reason why we just call it the new normal, just like we all like, opportunities are there, we got to jump on them, we got to do something. But like, this is not a sustainable mindset, first of all, right? It's like, oh, wow, like, the last 2 months, like, yeah, you can sprint for 2 months on something. But I was like, okay, looks like we're in a marathon now. Like, this is a different game. And this is like the game, yeah, like the thing we're trying to adjust to now.
Yeah, that makes a lot of sense. You definitely can't keep up that pace for however long it takes to get these things under control, which who knows how long that's going to take.
Yeah, my main argument for the slowdown is just like for personal holidays, you know, things would just be, which is great. I would love a 6-month pause. Just like, yeah, there's like so many other things I would do.
Yeah, I think it would give a lot of people an opportunity to get their head around what's going on, for sure. So, I mean, you briefly mentioned it just before, the AI production function. So You've described this production function as basically having 3 inputs: algorithms, data, and compute. And the premise of what you're working on at the moment is very heavily focused on the compute angle, and that is a particularly promising vector for AI governance. So can you start by just describing those 3 inputs and elaborate on why compute is the most promising one from the governance perspective?
Yeah. So with the AI production function, I think like it's a neat way of thinking about it. We have like inputs, things we like throw into this black box in this production function, out we get is a machine learning system, like a trained algorithm eventually. Free inputs, algorithms, data, and compute. What do you mean with algorithms? With algorithms, we mean something just like, well, neural networks, or like most recently, like the transformer architecture, or other certain algorithms, how we learn these systems, stochastic gradient descent. So like this is like the underlying things we eventually do there. As we talk about machine learning systems, they need to eventually be trained on something. So we have data, right? Those are images, text, whatever kind of system you're eventually talking about there. And if to eventually run all of these systems, we need like computational infrastructure to feed the data into there and train the system via this one. And I think what's important to understand there, I'm excited about compute relative to the others. I think there's some pretty neat properties compared to algorithms and data. I think the most interesting one is like it's actually like a physical good. We talk about eventually a semiconductor which is sitting somewhere, whereas like algorithms and data are on your computer. The thing about things on your computer, you can literally just like press Command-C, Command-V, and you duplicated it. This is way harder with chips. There right now is a finite amount of chips out there, amount of compute out there, and it's a finite amount of compute, how much you can process, right? There's like a certain number of floating point operations per second, which I can crunch right now in the world. And if I want to get more of this, well, I have to produce it, right? So this type of executability function of compute makes it like a really interesting angle, right? If I'm using my laptop right now with 100%, nobody else can use it. And that's like a pretty good tool to do. Whereas like if I publish a paper with an algorithm, everybody can use it. We can all use it at the same time, right? So I have like some way to eventually restrict access to the computing resources.
Interesting. Yeah, I suppose one of the things you've written about it quite a bit is like the supply chain sort of basically enabling this restriction. So can you maybe elaborate a little bit there on what aspects of the infrastructure or the supply chain actually make it so bottlenecked and able to sort of have these properties that allow it to be governed or potentially?
Yeah, I think it's useful to like differentiate between just like what I just described, like this executability is to some degree like a fundamental feature. Computers by definition executable. But if I would only need one chip where everybody could train, or you could like literally produce a chip in your microwave, it's not that excludable after all, right? I would be having a hard time controlling it. Even though there's a finite amount, I can produce a lot of it, right? So another feature of like chips is the semiconductor supply chain, which I would roughly describe as probably the most complex supply chain we as humanity have ever created. So to eventually get chips out of this, which we then use for training AI systems, we have like a complicated supply chain, semiconductor supply chain. We have like roughly 3 steps. We have first the design phase, where somebody thinks about on a high level, well, what is this chip going to be doing? I'm going to be designing it, the architecture, how can I add 2 numbers, these kinds of things. And eventually this boils down to like, how do I arrange transistors somewhere? Then I try to arrange these transistors. This is what we do in the fabrication, where we have famous companies like TSMC, Samsung, and Intel producing these chips, which are also the 3 main players when we talk about cutting edge nodes, where we talk about where the transistors are the smallest and therefore also the most performant processors we have. Interestingly enough, for like the most advanced transistor we can produce, why at TSMC or Intel, there's only one manufacturer who can produce the machines which feed into this fabs, which is ASML, which is sitting in the Netherlands, right? And the last step would then be the assembling and packaging, where you have like your finished chip. You need to get it out of your wafer, right? You have like produce many chips at once, and then you try to package it and assembly it, and out you got your finished chip. What I think is useful to also think about is like to think further than the semiconductor supply chain, also think about the compute supply chain. So we go one step further. I have the finished chip. Where do most chips end up? Well, some chips end up in our smartphones and our laptops. I'm particularly interested in AI chips for data centers. So the majority of all chips which are used for training and running AI systems nowadays end up in data centers. And the notable features now across the supply chain are, well, there's one company in the world who produces the machines which produce these chips, ASML. Then we have 3 companies who produce like cutting edge leading nodes, Intel, Samsung, and TSMC, with TSMC having the majority of the market share and usually leading in this kinds of domain. And then lastly, when we also think about the cloud providers or compute providers, they're like roughly 3 compute providers, which is Amazon Web Services, Microsoft Azure, and Google Cloud, who also then own the majority of all this AI compute, which you eventually use. And this is pretty good from a governance perspective, right? Because this allows you to use these bottlenecks, these choke points, to eventually achieve your desired goals of maybe restricting or promoting access, right? So you basically reduce the governance problems to like a handful of actors who control the supply chain, right? And from there, we can also use these supply chains to then monitor it. And this is the key thing the US currently uses to enforce the US chip restrictions via the supply chain and the US dominance over the supply chain with some of their key allies.
Right. And would you say the US dominance over the supply chain and the restrictions they're putting in place or have put in place, is that the only example of how compute's being used as a vector for governance at the moment or for control? Or are there other examples out there in the world of how, other sort of mechanisms for control around these systems?
Yeah, I'm mostly commenting on AI stuff. So I think the export controls are just a big example, which is like out there, which I think is like a pretty big deal. Also, if you think about AI policy in general, I think it's like probably one of the most relevant policies passed related to this so far. Unfortunately, there are little AI policies in place up to this point. So there's like no other current example, which I'm aware of, where like computers actively being used besides the export restrictions. Of course, there are like many ideas out there which people like me and others are developing, even being drafted right now, be it in the EU, in the US, or elsewhere.
Okay. Are there any of those in particular that you feel are particularly promising or particularly likely to be adopted?
Yeah, adoption is really hard to read. I'm having a hard time saying like what eventually gets adopted there. I'd wish for a bunch of these ideas get adopted. One idea which I just in general like is just like, we just need monitoring to some degree. Like just knowing what's going on would already be like such a huge win. So if you just have an idea who is accessing compute or who has how much compute, is already a big win. But like if we would have something like a chip registry where you know like, oh, this company has that many chips and they're renting out to this, and this would really help, right? And particularly if we talk about the cloud providers who probably have the majority of all the chips, we would just like to ask them like, hey, can you please figure out who your customers are, right? And this is eventually also required if you think about the US chip export restrictions, because you don't need to have the chips on your desk to use them. You can use them remotely. And the chip export controls are not successful if the US also eventually monitors cloud compute usage by foreign actors, right? So some kind of know your customer regimes for cloud providers, I think is a pretty good idea. And it's a good first step towards having like just more governance capacity. So you would know who's training which system, how many compute did they access. If there's like an actor who access like, oh, I would like to have 5,000 chips for like 3 months, you could be like, okay, you can get it, but it's good to know for the government, right? It gives you an estimate. And this reduces the AI governance problem to like not a handful of actors, but like probably less than 100 actors who like have the majority of compute and use it. And this is like great for the governance problem because it's like only these actors matter. So like in general, compute gives you like this whole knowledge dimension of like which actors have access, how they're using it, and gives you some upper bound who's out there.
Right. So that really just gives you an idea of like who out there is using or trying to train systems or basically just drawing down on these resources. And then I guess it gives governments a way to know whose door to knock on if they're concerned about someone using a lot of compute.
Yeah, I think in general you want to think about like the angle of like just strategic foresight. I think the government should have just like, I mean, it probably also got just like some heads up like, hey guys, we're OpenAI. We're going to release the system in a couple of months and we think it's a big deal, right? Like, and it's literally a case right now, right? And like in the future, if we think just like systems are becoming more capable, governments should know about this and they should, first of all, be able to say no. It's like, guys, you're like doing this changes the world. Maybe not, right? Like maybe do something about it. Maybe you should get our defense system first up, something along these lines. We just need to think about this. And independent of like, if they say something, it would just be good for to then to react accordingly and just know what's going on there, right? If you just deploy a technology, whatever this kind of technology is, to hundreds of millions of people, I think it's fair for the government to know and eventually also for the people to know what's going on there.
Yeah. It occurs to me that it could be a really tricky problem to tackle just because there's so many jurisdictions involved. Like OpenAI is based out of the US, but they're deploying globally, I'm assuming. And so, do you think that compute somehow becomes less feasible or more feasible given that difficulty? Yeah,
I think so. Eventually, just like some jurisdictions matter. Like if the EU passes certain things, OpenAI wants to deploy in the EU, right? But it's just in their financial interest if it's not. So you could just like maybe have something like a Brussels effect, which we had before with GDPR, where basically their product uses like these kinds of rules. right? Because just like they want to deploy here, and it's like, oh, cool, we do this anyways, right? This is like why the EU AI Act might eventually just like be a really big deal, because just like the majority of the world ends up adopting it, because the European market just matters for like any kind of monetization of these kinds of technologies. Besides that, we currently right now don't need the whole world to come together for the US to restrict the access for China to these chips. What eventually US can do, given that they have like certain parts of the semiconductor supply chain, they can try to enforce this via their own companies and US personnel. They have like some tricks there how they can do it, and not just talking to some key allies. And the key allies being here the Netherlands, Japan, and Taiwan. And if they're on board, they basically control all the high-end chips in the world. And this would then also allow you to do it. I'm in general in favor of not the US doing their own thing. I think eventually we want like multilateral agreements on these kinds of stuff where people come together. It's like, okay, cool, this seems like a big deal. We should come together. Let's think about carefully how we govern this, right? And to some degree, you can be saying this is what the US has been trying to do. And there have been lots of discussion, I think also just recently at the G7, exactly about this, about restricting access to semiconductors and these chips. And this then helps you there, where at least one jurisdiction has like a lot of power over these kinds of things. But otherwise, like, different markets just matter way more. And I think the EU, the US, and the UK are probably the biggest actors there, just given the market size. And eventually, this is where the companies are based, right? With the US having the majority of the companies, like OpenAI and Anthropic, and the UK also housing DeepMind.
Perhaps you can briefly touch on why the US has been so concerned with China having access to these cutting-edge chips. I know you've talked about this in more detail somewhat recently on the China Talk podcast, so I'll put a link to that in the show notes. But perhaps you can just give a little bit of context on, I guess, the motivations behind the US bringing in these export controls, given that it is like an example of how compute is being used as a control mechanism. So
right. So, yeah. It's exactly hard to say what exactly the motivations are. There's just like public statements, which I can like try to reiterate, like see what the main points are, and I can also like try to say some things why I think what the explicit goal there is. I think like we can roughly say that like simplify two parts. There's like one part of the export controls which like stops Chinese access to semiconductor manufacturing equipment via various methods, where you basically want to make sure China is not able to produce cutting edge nodes on their own. The other part is there is a certain restriction on certain chips going to China. And now we need to ask, like, well, what are these kinds of chips which are going to China there? The US currently defines this by two metrics. The one metric is basically the performance, the computational performance in operations per second. And the other metric is the interconnect speed. So basically how fast chips can talk to each other. Then you have like this and conjunction of these two metrics, which eventually carve out certain chips which are not allowed to go to China. And these chips are most famously like AI data center chips. The NVIDIA A100, H100, right? So these chips, for the majority, get used as so-called GPUs, which go into data centers, being used, for example, for AI, maybe also for other workloads like climate modeling and other stuff. So it's not that the US is like blindly targeting any chips here, or like targeting consumers. Consumers don't buy these chips. Like, this is relatively straightforward. You exactly see the opposite. US had like trying to think about like, well, how can we just target these chips we eventually care about? Why do they care about these chips? Well, they explicitly say in their motivations like China has the proclaimed goal of becoming a world leader in AI by 2030. And they don't like how the Chinese previously have used certain AI systems within the military, but also how certain AI systems have been abused against certain minorities with human rights abuse, most explicitly the Uyghurs example there. And with not having access to these chips, I think it's like probably not true that this will affect like computer vision algorithms or something, like systems you can train right now. The biggest impact of these export controls are in the future. Because right now you maintain a threshold where it is, so future chips cannot eventually go there. And the important insight here is chips get exponentially better, right? Like if Moore's law continues being true, chips get like, I don't know, like every 2 years, they double in their performance. So every 2 years you have like access to like chips are only half as good, right? And like this really hurts and eventually to go about this.
Yeah, interesting. Do you think there's, at any point, there would be like an issue with actors who have restricted access to cutting edge chips developing ways around that in terms of higher quality data or higher quality algorithms as like sort of compensating for a lack of compute with the other two inputs?
Yeah, I think you can for sure say that like you frame your research agenda around just like what you have available, right? There is a pretty great paper called the Hardware Lottery, which makes the argument like, well, we've focused on certain types of machine learning stuff, because we have hardware available for this. If we would never have GPUs, maybe our whole research in general would look different now. You can imagine something same in China. They explicitly try to look into new computing paradigms, so like hybrid computing paradigms, like neuromorphic computing or even quantum computing. I personally don't think they matter that much for AI within the next coming 10 years. Further in the future, it's really, really hard to say in general. If we talk about just leveraging more data, well, the thing is, if you leverage more data, you just need more compute, right? Because you just need more training runs, you need more back propagation eventually to do this. So more data doesn't help you because data is basically, the amount of data is just like the direct factor on like how much compute you eventually need. What you're more interested in is like having more computational efficient algorithms, right? But it's not like that. Like other AI companies right now are just like, oh, compute is free. No, it's definitely not the case. They spend hundreds of millions on these systems. Like, let's say maximum 100 million, but like millions of developing these systems. They have like a strong financial interest in developing a better algorithm. We literally talk about if you find a 5% more efficient algorithm, you save them $5 million. That's a big deal. So you can kind of expect like everybody's trying this as hard as possible right now. I think the more interesting angle is there are certain chips which got banned and certain chips which did not got banned. So there's more of an angle like, well, we now banned high performance, high interconnect chips. So you can now still sell high performance chips, but lower interconnect chips. And we immediately saw NVIDIA reacting, producing variants of their AI data center chips for China. The H800 and the 8800 and the H800, which are just the same computational performance as the equivalents, but like a reduced interconnect speed. So more the question is like, well, they can stay computationally as intensive, but they maybe try to find other ways to have like more communication efficient algorithms to get around this. And this at the moment is also my major concerns with the current export controls, that these kinds of restrictions on the interconnect bandwidth are just simply not strict enough. They probably need to go lower down there to induce a penalty which is eventually big enough for Chinese actor to not be interested in training systems. A penalty of like 10 to 30% is like endurable. Right? If you think this technology is really important, you will just do this and pay for it. You eventually need penalties which are like in the orders of like 2x or 10x to like really make sure these systems are not getting developed, or it comes at a really significant cost when they get developed.
Yeah, that makes sense. All right, so I think it might be interesting to change track a little bit and discuss some of the I guess, promising ways you could use compute for governance. So what sort of vectors here are you most excited about? Is it something like onboard, on-chip hardware type things, or is it more of a systematic systems level approach to controlling access? Or what are you most excited about here in terms of the actual control mechanisms for the future, I guess?
Yeah, there's a variety of things. I think they're all pretty excited. Maybe I would start just like giving some notions what I eventually want to achieve, right? I think it's good to just think about like there are like roughly 3 things we can do with compute. There's the knowledge idea, which I just described. Who has access to compute are probably actors which matter. There's the distribution angle where it's like, well, you can give certain actors more or less compute. Maybe like less responsible actors get less compute, whereas more responsible actors get more compute. We see, for example, the US and the UK explicitly developing initiatives to give the academics more compute. This might be a good idea because you might have reasons to believe that academics are more likely to scrutinize systems or like build more safe systems. Not actually sure if this is true, but could be the case. So like this is just like one of steering at like the distribution. And the last angle is the enforcement angle. And I think like, for all the engineers out there, I think this gives you some ideas like, oh, how could we eventually do this, right? If we now go on the angle, just like, well, maybe there are mechanisms which I can literally implement on the chips, on the hardware itself, but maybe also across, I call it the tech stack. For example, you could also implement mechanisms on the data center level, right? Or like on a systems level, which is like a couple of GPUs, or literally on the GPU level. So anything which allows you to monitor eventually, or like restrict the access would be a good way. Another way how to think about this, which I think is like excited, like why tech plays an important role, is it can reduce social costs eventually. I think there's like a whole notion, I just call it like, I don't know, tech-assisted diplomacy or reducing social costs. I have the problem if certain actors promise me, oh, I'm not going to train system X. Trust me, this really doesn't work. We had like good examples of this with nuclear. So if we have some way to verify claims and like make these kinds of assurances, this just increases trust. I don't need to trust you. I need to trust in the math and the hardware, right? So if I can implement a mechanism on your hardware, which then tells me like, oh, look, he only trained systems this big on these systems. He did not overcome this threshold we previously agreed on. This would be really helpful, right? Because it would reduce the social cost. It does not solve the problem alone. We still need international agreements and people need to talk to each other, but they're more likely to eventually get these kinds of things. I think just like testing the enrichment level of uranium is the most like close example there. We're just like, oh yeah, you can enrich uranium to this degree, that's like fine, to this low degree, but like to this high degree, oh no, that's not fine. And then we just go there, we measure it, and then it's fine, right? This is one way of going about it. But like, as I just said, sometimes you need to go there and measure it. And that's the same problem we have with these kinds of mechanisms. I could not try to implement them, but everybody who has like any clue about computer science and computer security knows it's really hard to get security right? And like the worst thing you do is just like implement mechanism, it doesn't work, there we go, now we lost it, right? So you maybe want a mechanism which like, where you can first of all test maybe from the outside if it's still working. There are like some things which I'm excited about there. Or maybe you also need like inspection regimes where you just check like, hey, you got access to all of these GPUs. We all agreed we don't want to do certain things X. This is implemented. I just want to make sure, first of all, are the chips still there? And this thing which I implemented, is this still working, right? So like this whole notion of like technical people, engineers coming in is like, okay, guys, talking to each other is really, really hard. Here are ways how we can reduce social costs and like make assurances and the commitments and agreements easier. It's a great way going forward. Eventually, if this doesn't work, or maybe as a backup option, or maybe even also as an assurance option, you want to have certain enforcement mechanisms. It's like, okay, you violated agreement X, your chip is now going to turn off. These kinds of things are also interesting. And I think we're like in the early stages of like scouting these kinds of proposals, right? But there are like some examples in the real world which are like pointing to the feasibility of this. Not necessarily to the security of this, but in general, I think like people should like try to investigate this more deeply. I'm trying to get a lot of research more started there, but there's definitely more hardware engineers, software engineers needed on these kinds of problems.
Interesting. What sort of research there are you most excited about?
I think a great example is like just for people to just read the paper, which is called How to Catch a Chinchilla. And it's called How to Catch a Chinchilla because there's this AI system which is called Chinchilla, which is coming from DeepMind. And this paper by Yonadav Shavid discusses basically a whole governance regime around compute, how you can verify certain commitments. And it's great because it has a whole governance regime, but it has a bunch of holes in it or open questions in it where it's like, we need this, we don't have it yet, somebody should think about this. So this paper gives like a lot of intuitions, just like what we should do. So what are some examples there? We maybe want to have like certain proof of learnings where like some algorithms already exist, but I think we need more research there where you can prove I've trained a certain system. But eventually what I all want to check is like you have not trained a certain system, right? Like I want to prove of non-learning, right? You could imagine like really stupid examples, like if somebody just runs, if I have a ton of compute and I want to prove to you I'm not currently training a certain model, well, I can just mine Bitcoins, right? And I can mine certain Bitcoins with a certain hash rate based on the amount of compute you have, and I can prove this later on you on the blockchain. And it's like, well, you're like, oh, cool, yeah, I see it. You crunch this many numbers. Looks like you didn't train the system. Well, this would be a massive waste of energy and a bunch of other stuff. But like, it seems like it just like points towards direction like that, like some ways so you can prove you've done certain things while you've not done certain things. But many, many questions there. Another thing which I'm excited about, just like verifying properties of training runs. So we're having a hard time saying which systems are dangerous, which are not dangerous. But maybe in the future, we have like certain properties of training runs which make them less dangerous, more dangerous. The amount of compute required, just like how long the training run is one property. But you could also imagine like certain algorithms, you're more worried about algorithms which have a certain reinforcement learning component. The problem there is you don't want to give others access to your code because of like intellectual property concerns. So if you have like some automated way of verifying source code that it does not have certain properties in this training run, and then you can approve this training run, this would be a great way of doing it again, right? So like, again, reducing this amount of social cost, just like, oh, here's this program which checks if it has certain components on it. I don't know anything, right? We trust this formal mechanism to eventually do these kinds of things.
Right. It kind of makes me think of, I think Secure Bio is trying to do a similar thing with like DNA synthesis of like, you don't actually know a way to basically monitor that like other actors aren't producing certain strains of DNA or something that have small chunks of bad things in them. Yeah. So you don't need to know what the full thing is that they're actually like trying to synthesize. You just need to know, does it have the bad thing in it?
Yeah, indeed. And you want to do this in a privacy preserving way, right? For like these IP concerns.
Do you have a sense of what bad things you would be looking for in that context, or is that still an open question at the
I
moment?
think it's largely an open question, right? Like it's just like, as I just said, maybe one thing you can just look out is the size of the training run. Well, if I start a training run, I don't exactly know the size yet, right? Just like it just depends how long I'm going to run it for, how much data I have. But maybe there's some things which you can pre-commit. It's like, here's a training run, and here's how much compute I need. And it's like, cool, I'm going to confirm your training run for this amount of compute. And like, general meme which we're trying to push is just like, well, if you have more compute, this usually leads to more capabilities, all things being equal, which means also more responsibilities. That's the general notion we want to go for, right? Like a big thing why compute governance is interesting is because compute is an indicator for AI capabilities, most famously empirically investigated with scaling laws. Like bigger systems, more compute incentive systems have more capabilities. This is also described as the scaling hypothesis. And if you believe this is continuing in the future, which I put some credence on, it will continue in the future to continue being true. Another thing which is also true, all things being equal, if you have more compute, means you can run more inferences, so more copies of the systems, right? So the actor with more compute can run more copies of GPT-4. And maybe the person with like 1,000 copies of GPT-4 compared to just 10 copies is the more powerful one, right?
Interesting. So at what point do you think compute might become a less viable vector for governance? Is there a point where we maybe like settle on something and people find a way to sort of get around these compute controls? And I guess, how do you think that might shake out? And I guess what sort of timeline do you think it might shake out along?
Yeah. So I think it definitely could like reduce its, let's say, absolute governability factor or something. But maybe the relative factor will just be like one of the better inputs or something, right? Just given the fundamental features I've described. But as I just said, there are like some state of affairs. Like if everybody can produce a chip, well, it just becomes way harder to like eventually enforce this, right? If China would have a sovereign semiconductor supply chain, could produce as good as AI chips as the US and its allies can do, well, the controls wouldn't work eventually, right? So like these kinds of things are the things we want to look out for. I think it just eventually depends on really the exact proposal we have in mind there. Another things to look out for is just like, well, how reliant AI systems on compute? Maybe this like reduces over time. And there's definitely some component of like increased algorithmic efficiency or like over time, you achieve the same capabilities for less compute. And how this develops over time is like an important input there, right? If you at some point can just train, let's say, an artificial general intelligence, whatever this exactly now means, on your smartphones, like, oh, damn, this seems really hard to control. I'm generally pretty pessimistic how the world then looks like if you eventually can do this, right?
Yeah. Do you think it's going to be easy to notice when that's happening? So the point at which people are basically able to train higher performing systems or larger models with less compute, is it going to be that easy to tell? Because I could see a situation where someone trains a massively large model with much less required compute and then kind of hides their capabilities and maybe only shows it operating at a 60% capacity to the external world, but internally they're using it at 100% for potentially bad things or neutral things that maybe have like massive downsides.
Yeah, you could imagine this happening. I think right now it's probably not the case because a lot of AI research is like still happening in the open and like people are like pretty transparent. I think we will see like a switch towards like companies being less transparent and maybe also other actors, right? Particularly if you think about the military use of AI systems. That's just this whole notion is like, this is a big deal if true, and I would be surprised if they're like big discontinuities where just like, oh, here's this magic idea, here's this magic sauce, which eventually changes all of this. You could imagine something like this, and if they would just like reduce the impact of the world regarding its like impact, like the capabilities, because they're hiding it, then I'm like, first of all, okay with it. If they're just hiding it, if they're not using it, then it seems fine, right? But if they then eventually use it, you might like, well, how did this happen, right? If now we just see like if I would now see North Korea developing like really cutting edge AI systems, I was like, okay, what happened there, right? My first submission was like, oh, they probably hacked into a compute cluster. But even then, somebody should have noticed that. Like they figured something out. I don't know what, but it points towards compute being less important, right? And then you would see it. I think that's just in general just like a strong incentive towards then just deploying and using its capabilities, right? And it eventually also just want the government to come in there. That's just, I want people, and it's also being asked in the UAI Act, to report the compute usage if you deploy the system. Maybe I don't want it publicly, but at least I want government agency to keep a track on this, right? And then government agencies would basically run the same spreadsheets which I'm running right now, where I'm like trying to take a look at it. It's like, oh, is the thing which I'm thinking is true, still true, and to which degree is it true, and how does it change the governability of stuff? Yeah.
Right. And I guess one last question I have sort of around this topic before we move on to what sort of physical engineering you'd like to be sort of see in the field is, at what point would, or are you concerned in a way about misaligned incentives around sort of like the financial upside to companies who are producing the chips, selling the chips, and then like actually doing the training runs and profiting from the finalized model? Like how tricky is it going to be to actually bring in governance measures when there is so much money up for grabs in this space at the moment?
I think it's exactly the argument why we need to bring up governments intervening there, because there's so much money for grabs. So far, I think people have never thought about as compute as a governance node. They're just like, I think most hardware providers are pretty much disclosed from responsibility. And it's also like a hard argument to make, right? Like, let's just imagine like an AI system right now does some harm. There's a couple of steps you need to take before you blame NVIDIA, and there are even more steps you need to take before you blame ASML, right? And ASML and TSMC, they produce many, many chips. Only 0.1% of the chips they produced eventually create this harm. And I think in general we have often we blame like the people who deploy it, right? These kinds of things, not actually the manufacturer for some stuff. But the thing which I want to push for is like, yep, it's disconnected from it, but hey guys, it's a really good governance node. Like we eventually just really need to do it. And it's just like, you bring this technology to the world, it's like more like you just bear responsibility.
Right. So you'd like to see like culpability along the sort of the supply chain in some way?
So. Yeah. Like I think in general, like when we started, I don't know, deploying Facebook to the world, nobody really first blamed Facebook, right? Everybody blamed each other. It's like, oh, why are you even looking at this? It's like, at some point, it's like, they've just blamed the player. I was like, no. At some point, you got to blame the game, right? And I think it's the same notion that at some point they started blaming Facebook. They could have also blamed the compute. Like, technically, Facebook is run on compute, right? Like, this is bad. And my argument is like, actually, if Facebook would have been a rogue actor, or like would have done stuff and would have not followed the laws, they would have turned off the computer. It's that simple. That's how we deal with like if people deploy, like if they're selling drugs online, it's not that easy to find like who's deploying this. So how do we deal with it? Like we find the server and we turn it off. A lot of times this is pretty hard because they do it like via the Tor network, right? And these kinds of stuff. But it's eventually how we deal with it. And then we're trying to figure out who eventually did it there. So it's like, it's just the best enforcement node we eventually have. We want to use this one. And yeah, this is just a notion which I eventually want to get people to be aware of. In particular for AI systems, it is just a case, once they exist, it's really hard to fight a proliferation. Once an AI system exists, the majority of compute has been used, and then it's just an algorithm. It's a big algorithm, but again, then you can copy and paste it. Then you can hack into this. Another way how the chip export controls and other controls are not successful is, well, China cannot train systems, but I can just hack into computers and steal these systems, right? So like information security just immediately comes with it. And ideally, you would bring certain systems never into existence, right? Because they're just in itself so dangerous. I think that's a pretty demanding ask, but maybe it's an ask which is eventually warranted.
Right. Right. So who do you think are particularly well suited for work in this field? So I guess when you're thinking about the type of interventions that could be possible, the type of interventions that need more research put into them, what engineering disciplines, sort of skill sets, personalities, and things like that are you imagining there?
Yeah, I think like you can just say there's like various things you need across the stack. And with the stack, I roughly mean like, well, there's software. This runs on some type of like frameworks, and you have a compiler somewhere sitting between there. And at some point you see the hardware, right? This hardware gets designed, get manufactured. So it's like all these kinds of steps there. Where do we need most people right now? I think we need mostly people just like researching and developing these ideas, like to come out of just like me like vaguely gesturing at them to just like, here's an architecture. I'm not sure if people should eventually just design the architecture or something, because eventually NVIDIA and others need to do these kinds of things to implement it there. But I think it's good to have like examples of this, like architectures immediately can point to. For software stuff, like for example, this proof of learning, this proof of non-learning, logging certain stuff, verifying certain properties, this is to a large degree a software problem. So people can just design this. And this is also a problem, just like also a math problem. Like proof of learning is like, yeah, a pretty mathy thing when like if people actually think through this and like try to implement this. So like I think those are like pretty interesting angles there. You can go even further on a data center level, right? You might imagine at some point if like some AI systems are like going a little bit more rogue, you maybe want to have something like just like a big off switch in data centers. This is exactly the opposite what data center operators want, right? They just want redundancy. I was like, yeah, I know where you're coming from, guys, but maybe this whole thing, maybe there's like something in between that you can just like still turn the system off before it goes completely wild. It's quite common that people did this in companies when like ransom was going around, where it's like somebody had some ransomware on a computer and then just goes from computer to computer in the entire network. And someone's like, okay, the best thing is like we just unplug all the computers, and like in this idea, just unplug the network, right? So sometimes these really just like, yeah, stupid solutions, as stupid as it sounds. I think sometimes people should like actually look into this. So like across this whole stack from data centers to chips and these kinds of implementation details there. And the types of engineers who think about this are mostly, well, computer scientists, electric engineers, hardware engineers, these kinds of things. And a lot of times like also just specific knowledge is just needed. If you think about the semiconductor supply chain export controls or chip export controls, it's not about you designing everything. It's like about you having a deep understanding of these kinds of things. So basically, you need to know which, I don't know, like special gas do I buy from this random company in Germany, which then feeds into ASML, which then produces the machine, which we don't want to go to China, and how can I do export control? So like, what are the things which eventually matter to achieve the desired goal? The same for the chip specification, where it's like, okay, here's a restriction which says something about how many TOPS you have, how many operations per second you have, and what the interconnect bandwidth. And now you need to think about like, what's the impact of China producing a dangerous AI system? That's a pretty long chain, right? And this is not a chain which any policy person with a degree in international relations can answer, right? So I'm making a general pitch of just like, technical people, please consider AI governance. We are in desperate need in think tanks, in governments, in AI labs everywhere of like these types of people who just like work across these domains and eventually, yeah, implement this, not just scrutinize ideas, just explain stuff from first principle to these people. The qualities you're looking for there is just like people who just like, who are good at explaining their degree to their mom. Maybe that's a way of describing it. It's like you're able to abstract, where just like, if you tell me about your newest method to shrinking transistors, and now you tell me what's the impact on future AI systems. But like that's like roughly what I'm pointing at. I think that's like pretty useful. Like if you think about building the biggest social network in the world, I want you to think about like, cool, that sounds pretty fancy, and like this is a nice tech stack, and you connect 1 billion people. What are the impacts on society? Like you want to think through this chain. I'm not saying you answer this question, but like at least it should come up, and then you should talk to others and like think about this.
Interesting. So ideally, you'd like to see people with technical backgrounds sort of like all along the tech stack, basically understanding like how this cog in the system is actually like going to have flow-on effects to other parts in it, and flow-on effects not only to the ability for people to train and execute these AI systems, but also for governance as well. Like,
indeed,
how can we actually like use this cog as a lever for governing the system?
And sometimes the answer is you just cannot. It's like not relevant. I have like a bunch of people with like certain domain expertise. And I was like, gosh, like I don't even know if this is relevant. You tell me if this is relevant, right? This is basically a question you gotta ask yourself. I did a bunch of classes which are not relevant at all, right? But I also did some classes like my high performance class. I was like, cool. It's like really good for me to know how distributed training works. And I would have never thought it's gonna be relevant for governance stuff, right? I did a bunch of compiler engineering. Not relevant. I think it's like not like detailed relevant. I think like it still helps me. I was like, I have a general understanding how a computer works, and like I think like it fills a gap in like my world, like computer view or whatever. These kinds of knowledge, right? For understanding this, and also just being a bit of a generalist or something. People should sometimes be like a bit more agnostic about their background. I think engineers are this to some degree. I don't know, like I think I have like a bunch of engineers end up being at McKinsey. Well, they don't hire you because you know how a transistor works. Like, why do physicists end up in banks? Well, not because they know how quantum physics works, right? They're just generally hired for being like competent, mathy people, right? And I think that's just like, first of all, like for personal reasons, just a better way to think about yourself. Just like, I don't know, keep your identity small or something, right? Like pushing against this notion, I'm like this engineer or something. Maybe you should not even be an engineer. I don't know. Like sometimes identities are useful, sometimes they're not useful, right? And just think about like, okay, cool. What can I do? I'm just generally useful. What are the big problems out there? How can I solve them? Like sometimes if you have specific knowledge, see it as your personal fit. And sometimes it's particularly useful. And sometimes the answer is like, no, it's just not useful. I'm sorry. You got to pivot to something, maybe something closer. Maybe just give it up completely. You're just like a competent person who can run projects. Cool. Go about and do this.
Yeah, there's definitely still space for people who can just come in and provide those project management skills, which is quite a, well-developed skill in the engineering space.
Right.
Because, you just need to get physical things done and to a reasonable timeline and to a reasonable budget as well.
Yeah.
Yeah.
Or maybe like another way to think about it is just risk management. Engineers build airplanes, build bridges, build nuclear power facilities. Those are pretty powerful technologies, and they sometimes go not well. Most of them they go well. And this is not a random incident. This is because of risk management, right? Like anybody who's ever done some risk management, cool. Please come here and just basically apply the same principles to AI. Like tell me how they transfer. Colleague of mine basically, he once said like, all I'm doing is like, I'm just taking the things which banks do and just replace banking with AI. And this is basically my paper. And I think he's like, yeah, like banking industry is like regulated. We fucked up a couple of times. Now we're trying to do better on this, right? So we have new laws. It's like, it's somebody like, yeah, what about like third party audits? That's a good idea. What about internal risk management? That's a good idea. I think it's the same for AI, right? We don't have to reinvent the wheel here. We just have to be careful, like, okay, what is the difference between building an airplane, a nuclear power facility, and building dangerous AI systems? There are some differences, right? It's a typical interview question, which I like to ask. Like, okay, tell me what the differences there are. What are like transferable lessons? What are non-transferable lessons there? So these types of people, just like, again, it does not depend on your hard knowledge. I don't know which steel makes the bridge not collapse. This doesn't matter. But at some point, you thought about the idea which steel you use, right? And this is the kind of prompt you eventually want to have for engineering. Well, for creating AI systems themselves, but also creating the systems and the governance around AI systems.
Interesting. So for listeners, viewers, if they are interested in, I guess, testing their fit for working in this space, is there anything that you typically recommend people read, do, activities, connections?
Yeah, I think it's good to just like read about the AI governance problem. There is a great reading list by Blue Dot Impact. I think it's called the Artificial General Intelligence Safety Fundamentals course or something. There's a technical list and there's a governance list. Pick whatever people prefer. Maybe read both. Like maybe read across them. I think that's a good start. Just like trying to understand the problem and exactly know what's going on. And I think it also gives you the angle where it's like, I'm X. I've been doing Y. This might be helpful there. I think that's like in general interesting, right? This is outside of what I was like, oh. Compute, here we go. How can engineering be helpful? And it's like, and then I kind of like thought about, it's like, okay, here's the thing. And what I just then did is just like I did a research project, like via 3 months, over a couple of months, as a research fellowship, just writing up like what is AI and compute. And I don't think I invented anything new. Like I actually look back, it's like, not the best takes there, Lennart. You could do better. Like, which generally is a good thing that you can do. Yeah, that you look back at your some pieces like you can do better now. But like it just clarified my own thinking. I think that's helpful, and ideally you do this like in a managed way. For example, what we do at GovAI, we run like 3 months fellowship 2 times per year, and I'm actively trying to get like more engineers to come just like join me. Let's try to make the pivot together. You have all of these people around you. They teach you governance. We try to do technical stuff and like be somewhere in between. That's also how I came in there. It's like, cool, I'm the techie person. You're the governance person. Explain me how this works. And like, yeah, I had some lessons where I was like, talking with a colleague, like he explained me bargaining theory, and I was like, okay, and here's how a computer works. And I think, yeah, this is just a great exchange, right?
Yeah, it's a good trade.
Any other resources or things to do? Get started, like do fellowships as a test. I think sometimes this is costly when you're already in a job. Maybe try to take a sabbatical. I think that's like sometimes a good way to go about it. Just like try to explore this, come up with stuff. I'm in general keen of just like try to not do it in a vacuum. Talk to people. Just talk to people, go to conferences where these kinds of things are being discussed, maybe conferences about AI safety, like all these things around it, maybe on AI governance, where you can chat about this, post stuff online, share your takes, just collect Don't do the stuff in a vacuum. I think this is particularly important for AI governance. there's just so much stuff which people are not aware of because just like people never published it. It's just a Google Doc you once sent to the staffer as a PDF, a bunch of stuff you're just simply not allowed to share, right, of confidential information. And sometimes people reinvent the wheel, which is sometimes still fine because you learn a lot. I think I did like at least 2 projects where I like learned a year later somebody did this and I was shared on this Google Doc. It's like, cool, 2 years too late, but thanks.
Yeah, but then it's out there as well.
Then it's, like ideally it's out there. Sometimes it's still not out there because like, it's just a bad idea to publish it or so. So talk to people. They're like sometimes they know more about stuff than they do, and they can just point you in a general direction or like can connect you to others. I think if you tell me like, what about this problem? I can tell you like 2 other people you should talk to, and this would then eventually help to make better and faster progress on these kinds of things.
Interesting. Are there any particular good online locations for people to be searching for these connections, publishing their work, or seeing sort of examples of other people's work that's been published?
Yeah, I think like historically, a lot of this AI governance stuff has been coming around out of the effective altruism community. So I think, and maybe also the Less Wrong community. So lesswrong.com and forum.effectivealtruism.com has a bunch of things in this thing. Then just our website, governance.ai, there's a bunch of research there which you can click on, and blog posts where people can just learn more about stuff. But like these forums allow you to give feedback and where you can learn more about these kinds of things. I think the same goes with like eventually effective altruism conferences where just like a bunch of these people are hanging around. I expect there will be more just AI conferences in the future for these kinds of things. And there's also a whole academic field around this, right? Of course, it's kind of hard to get feedback there, like if you want to publish a paper, peer-reviewed, whatever. But again, this is how academically you get feedback. And maybe a lot of times just like looking at papers which you think are relevant, looking at the names and sending them a message. And as a minimum, just like, hey, I'm working on this, just for your information. I have a bunch of people reach out. I'm working on it. I'm like, cool. I'm like, hey, sorry, seems great. I'm busy. Here are a couple of resources might be helpful. Please send me the finished thing. As a minimum, this just seems great. And like maybe I'm happy to give feedback, right? You don't always have the capacity to supervise, but the capacity to give feedback is like, way more likely to be there.
Interesting. In the academic context, are there any particular labs or research groups that you're aware of who you'd like people to know about?
On these kinds of things, I mean, nothing on compute governance, unfortunately. On AI governance, gosh, I don't want to highlight any particular lab there. I think, just look at the big conferences there. Just Google AI governance, just see who cites whom or something, what's going on there. There's just like a bunch of stuff coming out of the labs, a bunch of lab stuff coming out of the think tanks. Many think tanks like us. Other think tanks which are maybe important is the Center for Security and Emerging Technology in Washington, D.C., the Center for New American Security, CNAS in D.C., the Brookings Institute is also doing more stuff on AI. I just expect every think tank in the future will be doing AI stuff. Some of them have just historically been a little bit ahead of the curve and just did it earlier. Many think tanks in the US, in the UK, being the Turing Institute, the Ada Lovelace Institute, all these kinds of places. Look at them, just Google AI governance. And as I just said, this reading list of Blue Dot Impact just gives you like a bunch of resources where you should eventually look at.
Yeah, awesome. We'll definitely put a link to that in the show notes as well. So when it comes to people who are concerned about AI safety and artificial general intelligence, my impression is there's typically 2 tracks that people are considering. It's either the governance track or the AI technical sort of safety work. So more like actually like creating models, playing around with them and trying to sort of, I guess, understand how they're working a little bit. How would you sort of advise somebody who's interested in contributing in the broader space between sort of selecting between those two tracks?
Yeah, I think people just try to build their own view, ideally. Whether just like, I think some people have the view, it's like, governance doesn't matter, politics is the mind killer. And maybe you have strong reasons to believe so. And if you actually believe this, I think governance is not your track you should be going for, right? If you just like undecided, my argument is like, we eventually need both. Like, I need people who just eventually make these systems more secure. I'm claiming they also need people like me to make sure these systems, we just get more time to make them more secure. We make sure certain actors don't get access to these systems, and we just deploy them in a more safely and more responsible manner. And like, governing this whole thing. I think it's a personal fit decision to a large extent. If you're more of the people person, I would say like, well, governance seems nice. You talk to people. Maybe you want to be more on the policy side of things. But also within governance, there's just like a broad spectrum. You can like do a lot of desk research, strategy research, where you're just sitting on a desk. You don't need to talk to anyone. But I think probably governance happens less in a vacuum than it might do with technical research, right? There is nothing good for me to develop a good AI governance regime or proposal if I don't bring it to people, or like they won't adapt it by default is my claim. Whereas if you tomorrow know how to align AI systems, I think there's like some reasons to believe people will adapt it by more default, like because it also makes the systems probably more useful and like, interesting for others. So yeah, personal fit, where you're coming from, these kinds of things, who you want to work with, where do you think the problem is. A lot of times it's just like location constraints or something. If you're like a poor person like me who's just been born with the wrong citizenship, so-called like you're not a US citizen or a UK citizen, it just limits some options, right? You maybe will eventually want to move to these countries, but it slows down everything a tiny bit. I think Germany, which is my citizenship, just doesn't matter that much regarding this kinds of stuff. But maybe the EU does matter, right? So maybe I should like, my personal fit is more in the EU. And maybe if I have no particular strong preference because I really want to live in Germany, there's little places where I can do technical AI safety research, like little labs there. So maybe I can just do governance because it's closer, I can stay there where I live. I think people should take these considerations like actually serious. You don't exist in a vacuum. You're part of a community. It's great to help the world, but just like if you move around the world, please take care of yourself in general. These kinds of things. General advice, talk to 80,000 hours, ask them for advice. They're like way better at this than I am. And all the things you can read online, they can talk you through these kinds of things. And just give it a shot. Try both. I tried to take my hand at AI systems. I was like, cool, this seems nice. I kind of enjoy it. I still have it as a backup option. There's still like a part of me which is like, okay, like every year I sit down and I'm like, am I still on the right track? First of all, is this AI thing really, Lennart? Like, what the hell, really? I was like, and this year, like last year I was like, seems pretty good. Seems like a big deal. I should work on this, right? There are like many problems in the world. I was like, right now I think like this is a particular pressing one. So like, I'm trying to think about like, well, is this the right problem? And then like I was like, well, governance, really? So is this the thing what you're doing? Do you actually think we can get this done? And I was like, I look and I was like, yeah. I feel so. Like I feel more excited about governance than I initially used to when I came into this. I think I was like a cynical technical person who was like, we got all the solutions, guys. You just need to implement them, and you don't do it, and like this is terrible, and I don't want to play this people's game. And I actually think like, no, there's a bunch of things we still need to figure out there. There are some people like some networking stuff at play, or so you might want to enjoy this if you do policy. But yeah, this way that you cannot achieve anything, right? It's just simply wrong. Like it's happening right now. Like, this year, we're like this and next year, we're just like show ourselves if we can get anything done, at least regarding to policy. And I think we already made like a bunch of progress regarding governance at the labs. There could be a world where the governance at the labs itself would just be significantly worse, right? And we have like some examples of labs which are more or less responsible already out there, where we can already see it makes a difference. It could be way worse.
Yeah, it is reassuring that there's at least that glimmer of hope, or at least there's a counterfactual world where things could be much, much worse.
Yeah, I think so.
Had big labs just not had governance on their mind at all, and just gone
like
and done
OpenAI
whatever
and
they
others
thought.
could just be way more responsible. I'm not saying they're responsible enough right now. You can always do better, right? That's the thing which I'm advocating for. But gosh, you can just be like way worse, right? And like I think there are like some examples out there, like Meta, where it's like, okay, clearly there's like some differences there. We should chat about it. We should have an open discussion about it, right? But I currently disagree with some of the practices, right? And I think they could do better on this.
Then to finish us off, what do you wish you had invented and why?
Yeah. I mean, I guess the obvious answer is like the solution to the alignment problem, right? Like this would be great. So somebody please can do this. I would love it. The other thing which I was just thinking of, like a thing big hassle in my life right now, is just traveling. So teleportation would be great. but let's be more realistic. Like hypersonic travel, just like I can sleep on planes, like affordable, cheap, carbon neutral travel. Would be great. I can just go places. I can just be wherever I need to be, fast and smoothly. If I could just we have these night trains back in Europe. It's just great. You like go there, you sleep, and you wake up in the next city. This is great. This is like kind of teleportation, just in a hacky way. More of that. I would love it. Yeah.
I would love that too. As someone who's mainly based in Australia,
right?
That would be
you guys.
That'd be terrific. Yeah. Well, awesome. I guess before we wrap up, any final things you'd like to plug? Where can people find you online? Learn more about the research you are doing?
Yeah. In general, every engineer, technical person out there feeling encouraged to AI governance. I think my take right now is like not enough people actually considering it. I would be pretty keen on people more trying this. And yeah, I'm on the internet. You can find me on Twitter. It's Lennart, Lennart. And also, I got a website where I sometimes post some stuff, or you can at least click on links and see my publications and everything else, which is Heim, which is my last name, HEIM.xyz, where you can find me. I guess we'll also link this just in the show notes. And then, thanks for having me.
Terrific. Yeah, Lennart, thanks so much for everything you're doing so far at GovAI and all the research you've been putting out there onto the EA forum and giving physical engineers some hope that there are some things that they can do in the AI safety space that actually looks kind of like engineering, and maybe just applying those skill sets in a slightly different context.
Yep.
Thank you very much for joining me.
Thanks for having me, and thanks for spreading the word.
I hope you enjoyed that conversation with Lennart. For detailed show notes and links to learn more, please head to engineeredforimpact.show/Lennart. That's LENNART. If you would like to support this podcast, the best thing you can do is head to the show notes page and leave us anonymous feedback. We're always on the lookout for ways to improve the podcast and deliver better value to you. So we greatly appreciate any feedback that you can give us. Engineered for Impact is brought to you by High Impact Engineers. Thanks for listening and happy problem solving.